Hey everybody, let's give this problem a try. So we have some kind of solid disk. So I grabbed this entry for the moment of inertia from the table in the book, since I already saw that there's some disk. And then, let me just draw something. We exert some kind of force tangential to the radius. So tangent means like a tangent line means it only touches that circle at one point in space, right? So say like this. The force that's tangential to the grindstone. And then we know the radius. It's no, right here. It's known. Okay. And that's all for now. All right, so there's our free body diagram. There would actually be some weight, right? Let me get rid of this radius. All right, so here's the free body diagram. So let's sum torque about somewhere. So let's say if we pick coordinates like this. Let's see, how about if x is this way and y is this way, then z would be into the page, right? Clockwise. So positive z would be this way. So then the torque would be r cross f, which they're actually perpendicular, right? Because it's tangential to the surface. So r times f. And that's it. That's the only torque acting on this grindstone, equals I alpha. Okay, that's it, I guess. It's a disk, so we just take the moment of inertia, and that's that. Okay, what's the torque? That. So part A, the torque is just the 1, R times F. Let's see, do we know the numbers? Yes. 0.28 meters times 180 newtons. Punch that in the calculator. Torque in Newton meters. Okay. Part B. What is the angular acceleration? We have angular acceleration right there. So let's just solve that. So part B, angular acceleration is RFT over I. And I is, from right here, 1/2 mr squared. Okay, well, this r cancels that. Now you can plug in numbers, not before this step, right? When you're done with the algebra, then you can plug in numbers. 180 newtons over 1/2, let's see, where's the mass? 75 kilograms. And the radius is known, 0.280. There you go, right? So punch that in the calculator, something, 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 radians per second squared. Okay. Oh, there's a part C. Okay, so now, let me make some space here. Okay, part C. Now there's actually something causing, there's an opposing frictional force. Okay, so we have our tangential force here, and then that was acting at some radius r. But now there's some frictional force, a kinetic friction acting at some other distance here, d, I'll just call it d, which is 1.5 centimeters. Now let's sum torque in that positive z direction going this way. So in the positive direction, r times ft, and then in the negative direction, d times that friction force equals I alpha. Okay, now solve for the angular acceleration, which is this. So alpha is rft minus d times that friction force over the moment of inertia, 1/2 mr squared. And there we go. Just plug in numbers. R is known, 0.28 meters. The tangential force is known, 180 newtons, minus D. 1.5 centimeters, just be careful, 0.15 meters. The friction force, 20 newtons over 1/2. The mass is known, 75 kilograms. The radius is known. Right? And then plug in the numbers, something, 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 radians per second squared. Okay, hope that's helpful. I'll see you on the next video.